we present a novel method that calculates high-quality light transport between real and virtual worlds at interactive frame rates. To synthesize a video with computer-generated content, we first take an input frame. In the following steps, we consider interreflections between real and virtual objects. We use ray tracing to calculate differential direct lighting of the mixed reality scene, and use our new differential irradiance caching algorithm to calculate the indirect illumination of the mixed scene. The final solution is produced by adding the results of the differential direct and indirect lighting to the input video frame. We achieve global illumination of a mixed reality scene. Accurate irradiance is evaluated by Monte Carlo integration at sparse scene points, shown on the right, called irradiance cache records. Their irradiance is later interpolated and splatted to the screen space by using irradiance cache splatting. A virtual box with a dragon is rendered into the real video. Global light transport in the mixed reality scene is calculated by differential irradiance caching. A comparison between rendering with direct illumination on the right and global illumination on the left can be seen. Indirect illumination introduces light and shadow regions and causes color bleeding. The scene is lit by a real lamp. The reflected light from the virtual dragon causes color bleeding on the real table. The position of the moving light source is correctly estimated and used for rendering. Reflected light and the shadow cast by the dragon change according to the direction of light. Limited information stored in the irradiance splat buffer causes rendering errors for pixels on edges in the case of depth of field. We overcome this problem by using a reprojection technique to access the irradiance splat buffer. The correctly smoothed image can be seen on the right. We created a global illumination framework for mixed reality where diffuse light transport is calculated by differential irradiance caching and specular light transport is calculated by ray tracing and photon mapping.